Okay, in this recording I'm going to go into detail about functions and what are the things that we need to remember about them, how do we actually go about writing them. You've already seen some examples, so you're probably pretty much okay with them, but it's important to go through the detail. So as I mentioned earlier, there can only be one main function, and in fact there must be one main function in any program. So everything that you want executed must either be in main or it must be called from main, directly or indirectly. So it can be called from a function that's called from a function that's called from a function that's called from main. That's fine, but in some way it must be called in main at some point during the execution of main. First thing I want to show you here, so you can see that I've got the whiteboard open here. I want to show you the anatomy of a function, in other words, how is it laid out. So there are 6 parts that you need to remember. 2 of them are very simple because they're both braces, but important things are the name. So the name of the function. We must send it the parameters. Now these go under a few different names. Parameters is one of them, and they're sometimes called arguments. Okay, just about shove that in there. There's the return type. So the return type must go here. We need our opening brace and we need our closing brace. So we've got 1, 2, 3, 4, 5. The last bit is the body. So the body of the function, and that's what the function actually does, is all placed in between this opening brace and this opening brace. Now remember that brace there, that's the kind of curly brackets. If I can change to a text thing here, I'll just show it to you. So that's those type of braces there. Okay, they're the type you must use in this case. Now, so important here to figure out what these things are. The name, you make that up. Okay, and just like the previous video that I did for you where I explained that there were naming conventions for variables, I think nearly all the same rules apply for the name of a function. So in other words, you must use alphabetic characters from A to Z, be they lowercase or uppercase. You can't have spaces in there. You can't have a lot of the non-letter type characters such as percent signs, arithmetic signs, all those. You can have numbers, but you can't start the function name with a number and so on. So all of those rules apply to the name of a function. You must of course not use one of the keywords either, or use the name of another function or variable that it might get mixed up with. The return type, that will be what type of variable is returned. So that will either be int, char, or character, float. There are a few others as well that we haven't really come across yet, but they're the main ones that you've seen so far that could be returned. The parameters, again, you need to say what type of thing they are. Are they ints or floats or whatever, and you need to give them a name. So we'll look at some examples in a minute. The opening brace and the closing brace is fairly handy. Then the body of the function, it deals with what the function actually does when it's called. So again, in a moment we'll look at a simple example where we just add 2 numbers together. So that's what we're going to switch to now. Okay, so I've opened up a file here and I've a little bit of it written already. We have 3 integer variables, num1, num2 and sum, and we have our system pause and our return 0 put in there. So what we're going to do is we're going to write our function. And I'm going to write up the top here. You may remember that there was a little bit of a hassle occurred in one of the previous videos when I didn't put it before main, and I'm going to explain a little bit about that in a few moments. For the minute we're just going to play by the rules and do it exactly where it worked before. So I'm going to write a function to add the 2 numbers together, and I'm going to give that an appropriate name. So I'm going to call it the add int, because it's going to add some integers together. Now it should be pointed out that this is really only for descriptive purposes, for showing you how to do a function. Actually putting a separate function for adding 2 numbers together really isn't necessary. So this is really only for simplicity's sake that I'm doing that. So I've called it add int. Now remember that I could call it some sort of gobbledygook. I could call it that, Okay, but the reality is you wouldn't know if I wrote it that way what the function was supposed to do, so we're as well stick to an actual description of the function as its name. So that's its name there. So remember there are 6 parts that we must put in. So that's part 1 is the name. We need to put in our opening brace is another one, and our closing brace, so that's 3 of them put in. We need to say the return type, and if we're going to add 2 numbers together we expect to get a result, and that result if we add 2 integers together must be an integer. So if we add 5 and 7 together we'll get 12. So that is the type that will be returned. So I write int to say that it's going to return an int to me. Now my parameters, if I want you to add 2 numbers, I couldn't just say what's the answer. I need to say what's the answer when I add and give you the 2 numbers. So what I'm going to do is I'm going to send 2 integers. I'm going to call them x and y. Now, so there are the parameters that I've actually sent. So we see them there. There's my parameters, or my arguments. This is my return type. This is the name of the function. Okay, you must put the parameters comma separated inside brackets, and you must say what their type is. That's very important. Okay. So now, how do we add 2 numbers? Well, what I can do is I can make a third integer in here. I'm going to call it z, and I can say that z equals x plus y. So whatever 2 numbers that I send to this function, it'll add them together, put the result in z, and then we should return that to whoever called it. So we say return z. Now we've said that z is an integer, so returning z should be no problem. If we had put z as a float, that should cause an issue because it's expecting an int and we're trying to return a float. Now we'll be coming back to this in a moment and maybe making some small alterations to it, but for the minute what we're going to do is we're going to look at calling this. So what I'm going to say first of all is I'm going to put some values into num1. I'm going to say is 5, and num2 I'm going to assign the value 7. Now normally what you do at this stage to get the addition is you say sum is assigned num1 plus num2. Okay, and that's how we normally do it because we don't really need a function. But what I'm going to do instead here is I'm going to call the simple function that I've made, and it's called add int. And that function expects some information of us before it can actually do its job. So it expects 2 numbers, and the 2 numbers that we're going to send it are num1 and num2. Okay, so we're going to send those 2 numbers there, num1 comma num2. First mistake a lot of people make is they start writing in int here. That's not necessary, and in fact not only is it not necessary, it will be an error. That would suggest then that we're declaring that in 2 places. We only need to tell the computer once that num1 is an integer. We don't need to do it again, and therefore it already has that done. Okay. When we call the add integer function, it goes and has a look at its definition of add int, and it says, okay, I'm expecting an integer in the first place. That's okay, I've got an integer. I'm expecting an integer in the second place. That's okay, I've got a second integer. And that's the function called. Now what we will do at this stage is I'll just put in a printf, and that printf is going to say the sum is %d for an integer. I'll do a /n to make sure we're going to a new line, and then I'll say sum. Okay. So what will happen here? Well, main will get called, and we start at the beginning of main. We will make 3 integer variables, and the compiler will give a space for those. We'll then assign values to the first 2 integers, num1 and num2. Then we will, and you always do what's on the right hand side of the equals first, or the assignment operator. We call the add integer function, and we pass it num1 and num2. Now num1 is a value of 5 in this case, and num2 is a value of 7. They get passed to here, and in effect it's like saying x is assigned num1, and like saying y is assigned num2. Shouldn't really write that and in there, that might be just confusing you because it wouldn't be part of the C program. But it'd be like writing that. Now the thing is, we can't actually write it that way in our program here because they're not in the same place, so it wouldn't work. But it's effectively the same thing that's happening there. So num1 gets put into x, num2 gets put into y. So the value of x when we get to this add integer is a value of 5 and y becomes a value of 7. We then make a new integer variable called z, so we get space for that. We say z is assigned x plus y, so 5 plus 7 get added together and they go into z, and then we return z via the integer. Now what that means is that z is a value of 12, that comes popping out of here and over and into sum. Okay? And once it's in sum, we can then print that out via this mechanism here. Now, what I'm going to do is I'm going to take this and I'm going to put it down here. So I put it afterwards. And I'm going to run that. Okay, the sum is 12, so it's managing to do that anyway. Now, as we've seen that worked properly, which is a little frustrating actually for my purposes here, because it shouldn't have worked properly. Now, part of the thing is that as many new compilers come along, they sometimes make things easier on people than the rules normally expect them to do. That's fine, but part of the problem that brings along then is that if you then move that program to another compiler, it won't work properly and you may not know why. So one of the things that I'm going to mention to you here, and it's important that you keep it in mind, is the proper way to actually where to place your functions and how to do it. As far as I know, the last time I tried one of these, it actually came up incorrectly, so I'm not sure if it's if the reason it's working this time is something to do with the compiler allowing it to happen, or something that I've done slightly differently. But in any case, the rules are that if you place the function after where it's called, okay, so it's called here for the first time here, and if we went down in logical order here, we get as far as here, and we see this add int, and we'd have never heard of it up to that point. A little bit like if I ask you to do something in C programming but you haven't watched the video first. So what you either do is you can either place the entire function up here so that it has seen it before it's ever been called, or if that's not convenient, you can write what's called a function prototype or a function declaration. Okay, so the function prototype looks like this. And it just has a semicolon at the end of it. So all that says is that, listen, later on there will be a definition of this function, but this is what it looks like, so that if the compiler comes across this, it can check, is it being called correctly? In other words, are you sending it an integer first and an integer second, or are you doing it incorrectly? So this is known as a function prototype, and it's quite important because the other place that these get put are inside these header files. Okay, so if you make a library of functions, just like the guys made the library of printf functions, if you make a library of functions that are useful to somebody, you can put a load of these declarations inside a header file and then have your definitions somewhere else, and anybody can pick them up and use them properly. Strictly speaking, because of the fact that all this is here, this is only here to just test the situation. Sometimes some compilers allow you away with not actually putting in the names of the variables. We'll just see if that allows us here, and it does. It runs no problem. So in many cases you just need to say, listen, there's an integer first and an integer second, and it's down here that you actually give the variable names. I still think it's handier if you just give a name of a variable up here, because it kind of keeps it better in your mind. Now, just to go through some of the details of our function here and what we have. Firstly, a function can only return one thing, right? So we're returning the sum of two numbers. But if you have a more complex function that might want to return 4 or 5 things, you can't do that by this method of just sending information out through the return statement. Now, for the first large part of the year, that won't be a problem. You just make sure that you're only returning one thing from a function. But there are situations in which we can do it by a backdoor mechanism. In other words, where we don't actually send it through the return function, we do it by another mechanism. Okay, but for the moment, from your point of view, you got to just remember that we can only return one thing from any given function. Okay, and that much, and you must decide whether that's an int, a float, or a character, or whatever other type. If you don't intend to return anything from a function, and that might sound unusual at first, but there are actually many situations where we don't actually intend to return anything, what you should do is use the void keyword here. Now you've seen that previously up here where we didn't want to pass main anything. In that case, what we do is we say void, like that. What I'm going to do is I'm going to change it in my prototype up above as well, void, and we'll see what happens here. Okay, this has come up with an error and it said void value not ignored as it ought to be. Okay, and what that means is that this function is supposed to return nothing, and yet I'm clearly using it here as if I'm expecting something to come back. Okay, in the function addInt it says warning, return with a value in function returning void. So it's saying you're returning an integer, but you've said you're not returning anything. So immediately there, the compiler is helping you out here, where it's clearly seen that you've made some sort of mistake and you're not sure what you're doing. So a lot of people panic when they see errors appearing. In actual fact, errors are quite useful, because if you get errors that, if you have problems in your program that the compiler doesn't spot, they're usually much harder to solve. Okay, I'm going to change that back to an int here. And change it up above to an int. Now just to reiterate on the information about the name, remember always to check, is that name in use anywhere else? Okay, so check, is it being used by another function or another variable, and always try and give the name something that actually describes what the function does. So this function adds integers. Okay, now just to show you what some people might come up with is they might say we should call that function sum because it's going to sum two things up. So let's do that. Let's change it to sum. Okay, so I've changed it in both places. There are some there, and therefore then when I add the two together I say sum. Okay, and something has gone wrong here. It says here that and I'll just double click on it there, so when I double click on it, it shows me where the error is. It says called object is not a function. Okay, so it's saying that sum is not a function, and it's dead right, because we've made sum an integer here. So what's happened is that sum there is conflicting with this sum here, because the two are off the same name and the compiler doesn't know which you're talking about. Okay, so be wary of that. Never call a function the same name as another function or another variable. Okay, so what I'm going to do is I'm going to write another function now, and this one is going to calculate the area of a rectangle. So the first thing I'm going to do is I'm going to write the function prototype up here, and I'm going to decide on an appropriate name. Now you can think yourself for a moment as to what you'd call that, but here's some possibilities. I could call it area, but the problem with that function name is that could be the area of anything. We don't know that that's the area of a rectangle. So I could change it to area rect for area of a rectangle. Now this is better, but the problem is that would actually be a very good variable name for what we would return from this. In other words, we would return the area of the rectangle. So really and truly, the function is a doing word, it's a verb. So what we should do is call it area rectangle calc. And that's then an excellent name to call the function, because that describes exactly what it does. Okay. Now, our next piece of information is we need to decide what we're going to send to it. Now, of course, the area of a rectangle, we could be, let's draw some lines there. They're not very straight. Actually, I'll use the straight edge here. Okay, so rectangle here. Okay, so we've got a rectangle there, and we're going to have a length and a width. Okay. The length and the width could have fractional parts, so there could be floating point numbers. But for the sake of this one, we'll just do them with integer numbers. So I'll say int length, int width. Okay, and again, length and width are good names to give those. those parameters that we're going to pass to it. Now, the next thing we need to decide is what are we going to return. Now, we could return a float or an int. If we've got an integer for length and an integer for width, two integers multiplied by each other can only return an int, and therefore an int should be fine as a return. Now, what I'm going to do is down here I'm going to, I'll actually write my function first. So I'll grab the area of the rectangle there and write my function down here. So we have our opening brace and our closing brace, and then we decide what we're going to put into it. So we can put in int area rect. Okay, so you see there where I've used the name that we first were going to use as a function name, but it's better off here. And I say area rect is assigned multiplied by width, and then I return in the area rect. Now, so we'll call that function then. So I'll call area rect calc. I'll send it to a piece of information, so I'll actually use num1 and num2 again, a comma in between them, and num2, so that'll be a length of 5 and a width of 7. Now normally the length is longer than the width, but that won't matter here. And if I just call it like that, we can see what happens. We can run the function there. It says the sum is 12, but it tells me nothing about the area of the rectangle. The reason being that I've called the function and it's returned something to me, so it's returned area rect, but I've done absolutely nothing with that. It's just disappeared and it's gone now. Okay, so I need to do something with it, and in fact, even if I put it somewhere, let's say if I do this, I say int say rect is assigned area rect calc. Even if I run it like that, it still does nothing, because I've now got the value into this variable here, but I haven't done anything with it. I haven't actually shown it on the screen. So the last thing I do is I say area of rectangle is %d, do another slash n there, comma, area rect. Now, another mistake people often make is they start putting in area rect calc here or something like that. We've already called that function, so we don't need to do it again. The value is in here. That's what we need to print out in this section here. Now, the sharp-eyed amongst you will have noticed that I've used area rect here as a variable, and I've used it down here as well. I've made them both. I'll come back to this in a later lecture, but in effect those two don't conflict with each other because they're inside different sets of braces. Okay, so if you spotted that and you were wondering how can you get away with that, that's the reason. But as I say, I will come back to a full recording to do with the scope of a variable. Now, coming back to the issue of whether to use ints here or floats, I decided to use ints, and I said they're purely for simplicity. But is there a reason why we wouldn't just call them floats and be done with it? Because floats can handle everything, whereas ints can only handle certain numbers. Well, there are good reasons for it. As an embedded systems programmer, floating points normally take up more space than integers, and integers normally take up more space than characters. So in an embedded system, space is everything. And if you use up space that you don't need for a particular application, that's space that you won't have then for something else. So it is important that you don't use larger variable types than you need for your particular application. So try to stick to that rule wherever you can. Always stop and question, why am I using this type of variable? Do I need to use it? Could I use a different one? Or do I have to use a different one if, for example, we're going to have fractional parts here? Now, lastly, I'm going to show a few shortcuts that we could have made. This is just little optional lectures to show you kind of different ways that you could have done things. Again, as I say, these are so simplistic that we wouldn't normally write a function for them at all. But in our case, just for instruction use, we have done it. We could get away without using that variable there at all. And so we get rid of that, and we could just say return length by width. Okay. Now again, as I say, if we're going doing that, we may as well not have used the function in the first place anyway. But that's just to make the point. So that will calculate the length multiplied by the width and will return the overall answer to us. Okay, so that's one way of doing it. Another thing to mention here is where we've actually taken the value out here, and I'll do this with the sum one just to be different. We've added the integers together, num1 and num2, and put them into sum. We could have got away without using the sum variable at all, so I'm going to get rid of it there. What I'll do, is I'll just run the program before I do that, so that we make sure that the area of the rectangle is 35, so that bit is working correctly. But just to show you here, so I'm going to get rid of that sum variable. So I'm going to get rid of it from there as well. And what I'm going to do is I'm going to replace the whole lot of that in place of sum here. And so what now happens is, in the printf we say this sum is %d, and it goes to find an integer and finds that the whole function is there. It has to run that function, get the answer back, and then put it into there. And that's what will happen. Okay, so we still see that the sum is 12, so that is still working correctly. Okay, so that's it on functions for the moment. As I say, I will come back and do a little bit more information on the scope of functions and so on. So it's not the last we'll see of them, but it's important that you get those few pieces of information into your head.